Okay, this video is going to discuss how the computer is eventually able to use the code that we write and produce output on the screen and do things that we would want it to do. And so before we get started though, some important situations here is just to know, because I haven't mentioned this yet, but up here we have 1.1 and 1.2 flashcard terms. I would suggest that you start making flashcards in Quizlet of these terms, and eventually I will have an assignment where I'll ask you to turn in a Quizlet having to do with these terms. So you might want to get started on that, start studying these things. These are kind of things that can be on quizzes and tests eventually. And then there'll be another set of words on the after the end of 1.3. So that's just a little side note here. Now what we want to do is we want to look at this Java programming language and see how does it get from the code to where the computer actually can use it. So Java, along with other programming languages like C, C++, Python, etc., what they are is they're called high-level programming languages. Okay, so they're called high-level. Now, in our class, we are going to, as programmers, we're going to use Java to write our source code. And we've already discussed in this class before that this is source code. This is Java. This is a high-level programming language. And so let's get back to here. And so that's what we're going to be using as Java. The problem is that the CPU, which stands for Computer Processing Unit, can't read high-level programming languages. Okay, the CPU, Central Processing Unit, cannot read the high level. It can't read Java. It doesn't go straight from Java to the computer. So the source code must be translated into machine code. Okay, so it's got to be translated into something else. So it's just like when someone maybe speaks to us in Spanish and we don't understand it, somebody else can come along and translate it into a language that we can understand. And so that's basically what's going on. So the source code must be translated into machine code that can be read and executed by the CPU, the Central Processing Unit that every computer has. So as we move on to the next page here, we're just going to give a simplified diagram of what happens. So the first box is going to represent the source code. So that'd be what you'd write in here. This is the code that we, of course, write in our JGrasp in the upper pane. Now, if you remember, after we got through writing this code and we saved it, we had to click on the compiler, the compile button. And so in doing that, so what we have here is the compiler button. So compiler, so just type compiler or write compiler in this box. So we start the source code, we go to the compiler translates the source code into a class file. Okay, it translates it into a class file. Now, this class file sometimes will have what's called hexadecimal code. So there's binary code, which just uses basically binary, just uses zeros and ones. So it's just a bunch of zeros and ones. Okay, and then you have an octal code, which uses adds some. You actually uses, I believe it's from 0 to 7, and then hexadecimal will use from 0 to 9, plus it'll use some letters. And so anyway, so if we go back to our code here, so here's this Java. Notice on the left we have a Java file, and so we compile it, and it's fine. But notice what a class file. So the compiler translates it to a class file, which contains, which actually can have a hexadecimal type. So you'll see it has numbers like 1, 6, 8, but it also has some letters in it as well. Okay, an A and a B, and etc. So that would be hexadecimal code right here. And so let's take a look here. And so the class file, which oftentimes will have hexadecimal code. Now, what happens is that the hexadecimal, or the class file, and the Java library files are taken by what's called the Java virtual machine. Okay, the Java virtual machine, which we just say JVM for short because we're lazy, will now translate this hexadecimal code even further. But also what's being used in this Java virtual machine is Java library files. So we're going to take a look briefly at that. And so here, first of all, it's going to take this code in here, the hexadecimal code, and it's going to take library files. Now, the library files there's a huge library that no person knows everything and has everything memorized. But just to give you an idea, inside this library, it's going to show something that you've already seen before, and that is println. You've seen println already. And so this method here is part of the Java library, and it's automatically used in our Java files. So this code then, well, let me mention this first. And so in addition, if we were to look at anything, anytime you click on any of these things, you're going to have a whole other set of files and things like that, or methods and things. And some of them have much more, like here's a bunch of methods and so forth. And so in fields and all that kind of stuff. Some of this stuff has to be imported into our programs, but some things are automatically available. And so that's the Java library, which has tons of stuff on it. And so the Java libraries and things that we have access to, or that has been imported into our programs or classes, along with the hexadecimal code, are used by the Java virtual machine, or the JVM, and there's another translation that goes on. In fact, there's a thing called the Java interpreter, and it translates it to what we call machine code. And oftentimes that might be called binary. Sometimes it's called a low-level language, programming language. So a low-level programming language is a language that's close to what the computer understands, or is one that is understood by the computer. And so then this is what the CPU then takes, and it is able to read it. It actually, it's kind of like when somebody translates the Spanish for us and they type out what it means in English, we can now then read the English, and that's what happens here. It reads and it executes, the instructions that are in this machine code. All right, and that's basically what happens. And then after when it executes it, of course, that's what produces the output on the monitors. Okay, so let's move on down. Then the JVM allows Java to be used really with multiple operating systems. It's a cross-platform. Because what happens is at this point of translation from here to here, the JVM recognizes the operating system and goes, okay, you're Windows 10. I will convert the code, the machine code, that Windows 10 can handle. And that's what makes the Java language so versatile. And so that's why it's such a good program to use. One of the reasons. The machine code produced by the JVM is made to be compatible with the operating system of the computer being used. Okay, so the machine code produced by the JVM is made to be compatible with the operating system of the computer being used. So if it's a Mac operating system, then the machine code is going to look different than it is for a Windows 10 or a Windows 8. The JGrasp, and so now that's basically what happens. Now JGrasp is called an IDE, which means an integrated development environment. An integrated development environment. So it's an environment where you can develop things. And so an IDE allows a programmer to write and test his program or programs all in one computer application. So it allows the programmer to write and test his program in one computer application. And so in here we can we write the code, we compile it, see if there's any errors, we fix the errors, then we can run it, and then we can see, is this what I want it to do? So we're running it, we're writing it, and we're testing it all within the JGrasp. Now, another thing that you could use is what's called a text editor. So Notepad in Windows is a text editor. So you can write your code in here. But then in order to test it, you have to actually run it in a different program, use a different software on your computer to be able to test it or run it and so forth. So it's much more complicated. And so that's why it's such an idea, a great idea to use an IDE, because it allows us to do everything all just in one program. The alternative to writing programs in an IDE, the alternative is to write programs in a text editor like Notepad. In Macs, it would be TextEdit. This method requires another program to run and test your class or your program. Alright, so that's basically it, and just remember you got flashcards here. These are flashcards. These are words that are in the textbook. Most of them I think are, and these would be good things to start putting in the Quizlet. And that's it for this section.